Hello students, welcome to YourPedia platform. I'm your mentor Rohit Singh and today we are going to discuss NPTEL assignment question of subject soil mechanics which is given on page number 174 as question number 131, right? So in this question they have given you a pile which is driven into a deposit of sand of 40 degrees and water table is at the depth of 2 meter below the ground level. Gamma value along with K, delta and NQ are given for this and they are asking you to calculate the ultimate load carrying capacity of pile. So let us start this question. So here they have given you a pile of dia 0.3 meter, length 15 meters and water table is at a depth of 2 meter and the gamma value above the water table is 18 kilonewton per meter cube and below the water table is gamma is equal to 20 kilonewton per meter cube, right? So along with that they have also given you K value which is 2, phi is 40 and delta is 3 by 4 of phi. So delta will become equal to 3 by 4 times of 40 which will be equal to 30 degrees. Now they have also asked you to consider the critical depth concept. Basically what is critical depth concept? Critical depth concept says that after the critical depth is reached, the sigma bar or the effective stress of the soil won't increase after this critical depth. It will remain same for the rest of the depth of the pile, right? So in this case LC is given as 20D where D is diameter of pile. Therefore LC comes out to be 20 times 0.3, this will equal to 6 meter. So after 6 meter of depth of pile, sigma bar or the effective stress will remain constant and it won't change. Okay, so now what we need to do is we need to divide our areas in a way that for first region till 2 meter of depth because it will be the dry soil, and till 6 meter we need to divide it into further second region to because we know that after 6 meter the sigma bar won't change, it will remain constant. So from depth 2 meter to depth 6 meter we will notify it as a region 2 and for the rest of the pile length we notify this region as region 3, right? Now we know that they are asking you the ultimate load carrying capacity of pile and we know that the ultimate load carrying capacity of pile is the summation of skin frictional resistance of pile plus the point bearing resistance of pile, right? So we can see that the total ultimate load carrying capacity of pile is summation of QS plus QB where QS is skin resistance and QB is point bearing resistance. Okay, and this is equal to AS FS plus AB FB where FS is K sigma bar average 10 delta and FB is sigma bar V into NQ for sand. This is for sand, right? And here in this case they have provided you a pile driven inside sand. Okay, so as you can see that in this formula we have K values given to us, delta is given to us, we only need to find the sigma bar average value for these all three regions. Okay, so now our main aim is to find out the sigma bar average for region 1, region 2 and region 3. So we know that the sigma or the sigma bar at depth of 2 meter will be equal to gamma 1 H1 where gamma 1 is 18 kilonewton per meter cube and H1 is 2 meter, right? So our sigma bar at depth of 2 meter will become equal to 18 into 2 which is 36 kilonewton per meter square. Similarly we can also find sigma bar at a depth of 6 meter because in this region, this is the most important region, because in this region the upper 2 meter will be dry soil and from depth 2 meter to 6 meter this will be a soil in the submerged condition, right? So we can find the effective stress value for at a depth of 6 meter as gamma 1 H1 plus gamma submerged into 4. Now what is gamma submerged? Gamma submerged will be equal to gamma saturated minus gamma W and they have given you that the gamma for soil below the water table is 20 kilonewton per meter cube, right? So gamma sat will be 20 and gamma W is already given in the question as 10. So our gamma submerged will become equal to 10 kilonewton per meter cube. Now we need to substitute the value in order to find the effective stress. So this will be 36 plus 10 into 4 because gamma submerged is 10. So it will become equal to 76 kilonewton per meter square. And we know that for region 3, the the sigma bar value will remain constant, since the depth is greater than the critical depth, and we know that beyond critical depth the sigma value will remain constant, or the effective stress will remain constant. So at sigma bar at depth of 15 meter or at the bottom of the pile will remain constant, which will be equal to 76 kilonewton per meter square only. Now in this question, let us draw the stress variation for the all three regions. So at ground level it is 0. At 2 meter depth it becomes equal to 36 kilonewton per meter square. Beyond this 2 to 6 meter depth it becomes equal to 76 kilonewton per meter square, and below 6 meter depth the sigma bar value, this is basically sigma bar variation, right? So sigma bar value will remain constant till the bottom of the pile. So it will remain constant till the bottom of the pile. So at bottom of the pile it will remain equal to 76 kilonewton per meter square. This is kilonewton per meter square, right? So but in the formula we know that we need to use the average value of sigma bar, and here in this question you can see that the sigma is changing along the length of the pile. So we need to find the sigma bar average values for all the regions, which is region 1, region 2 and region 3. So we know that for region 1, sigma bar average 1 will be equal to area of that triangle, which is, so area of this triangle divided by 2 meter length will be the average for this region 1, correct? So the sigma bar average 1 will equal to half into 36 into 2 divided by 2, which is 18 kilonewton per meter square. Now for region 2, one length is 36 and the other is 76, so the average will be equal to, the average of sigma bar will be equal to 36 plus 76 divided by 2, and this will come out to be equal to 56 kilonewton per meter square. And for region 3 it is very simple, because for region 3 the sigma bar will remain constant because the depth is beyond the critical depth. So the sigma bar average for region 3 will come out to be equal to 76 kilonewton per meter square only, because it will remain constant beyond critical depth, right? So now we have find out the sigma bar average values for all the regions. So we can substitute, we can independently solve the fs values for all three regions, and then we will add these values. So let us do this separately. So the QS value will become equal to AS1 into FS1 plus AS2 into FS2 plus AS3 into FS3. And we know that area of the pile, or the curved area of the pile, will be equal to, AS will be equal to pi dl, where L will be the length of each region and pi d will remain constant because diameter won't be changing. So from this you can say that the area will be, the total will be pi d L1 will be the area AS1 into FS1, where Fs is equal to K sigma bar average into 10 delta, right? So 10 delta and K will remain constant for every region. So this will be equal to K into 10 delta into sigma bar average 1, which is for first region, plus pi d L2 into K 10 delta into sigma average bar for region 2. After this you need to add the third region area, which will be pi d L3 into K sigma bar average 3 into 10 delta. And in this formula you have every value because we have already solved these values. So this will come out to be equal to, QS will be equal to pi, pi, d is 0.3 and length of pile for in the region 1 will be equal to 2 meter only, into k is given as 2 and average sigma average 1 came out to be, sigma average 1 came out to be 18 kilonewton per meter square. So this will be k, and 18 is sigma bar average into 10 of delta, and delta is 30 degrees, right? So this plus, similarly we can also calculate for second region as well. So this will be equal to pi into 0.3 and the length of the region 2 was, so this was the length of the region 2 and this was equal to 4 meters. You need to remember the lengths only, because the major point in this formula where you can commit mistake is in the length only, length and sigma bar average, because these are the only two parameters which are changing in every region. So pi d into length for second region will be 4 into k is 2 and sigma bar average 2 is, sigma bar average 2 was 56 kilonewton per meter square. So this will be equal to 56 into 10 delta is 1030. So this was for region 2. Now let us come back to our region 3rd. So this will be equal to pi into 0.3 into length of the region 3rd will be, so 15 was total length and 2 meter was region 1, 4 meter was region 2. So 15 minus 6 will be equal to 9 meters. So 9 meter will be the length of the region 3 into k is 2 and sigma bar average 3 was 76 kilonewton per meter square. So this will be equal to 76 into 10 of 30. Solve this and you will get the value of QS as, solve fast, use calculator and solve this, and you will get a value of QS as 1027.31 kilonewton. This will be the value of net frictional skin resistance given by the pile. This was the net frictional resistance given by the pile. Therefore, now what we are left is we have find out QS value. Now we need to find this QB, and we know that QB will be AB into FB. We know AB, and FB is given by sigma bar vertical into NQ. NQ they have already provided in the question. NQ is equal to 135 and sigma bar vertical will be this value. Sigma bar vertical will be at the bottom of the pile, because at this level only the point bearing action will be happening, right? So QB will be equal to area at base into FB, where area of base will be, so this will be a circular pile, so area will be pi by 4 d square. So this will be pi by 4 into d square into FB is already known to us, which is sigma bar vertical into NQ. All you need to do is substitute the values. So this will become equal to pi by 4 into d of pile is diameter of pile, which is 0.3 whole square, into sigma bar vertical, which is the effective stress at the base of the pile, which is equal to 76, and NQ is given as 135, and you will get the value of QB will be equal to, solve this and you will get the value of QB as 724.86 kilonewton. So now you have already calculated QS value, and now you have also calculated the QB value, right? So all you need to do is, we know that ultimate load carrying capacity of pile is summation of QS plus QB, and we have already calculated that QS is 1027.31 and QB we have just calculated as 724.86. so this is 724.86. therefore our QU value will come out to be equal to 1753 kilonewton, and this will be our final answer to the question. So now let us come back to our options, and you will get the correct answer as A, which is given as 1753 kilonewton. So the correct answer to this question will be 1753 kilonewton. I hope you understood this question. Keep watching for more interesting questions. Have a nice day. Thank you. Keep preparing. All the best.